Hello, everybody. This is Mark Hilton. Thanks for joining the event. We appreciate your time today. Before we get started, I wanted to go over a few housekeeping items just to make your online experience as streamlined as possible. First and foremost, if you have any questions while they're top of mind, you'll notice at the bottom right corner of your screen, you have a question pod. Simply type your questions in there. We have experts standing by to address them real time as the event unfolds. Also, during the event, there will be a screen share portion. When that portion comes, since you will be seeing someone's desktop, if you need to enlarge the area, it'll take the place of where you see the PowerPoint slide now, simply double click on that area or use little crosshairs on a blue icon at the bottom right hand corner, and that screen will enlarge for you as well. With that, I'm done with housekeeping. Matt, I'll turn it over to you.
Thank you. Hi and welcome everybody. Today we're going to be presenting on how to accelerate high-quality app delivery with the Micro Focus DevOps suite. Today is March 28th, 2018. Today's webinar will be sponsored by Micro Focus and hosted by me. My name is Matt Anger and I'm a pre-sales engineer with TaskTop Technologies. In my career, I've been using both HPE and Micro Focus ADM products, ranging from Quality Center to ALM to Load Runner to UFT, and other more specialized products such as Fortify On Demand, App Pulse, and Storm Runner Load. Grown to appreciate and respect the power of these products to improve software delivery velocity while protecting and improving software quality. My location is Babcock Ranch, Florida, America's first solar-powered city. And you can reach me at matt.anger@tasktop.com. Before we get started, I just want to say a few quick words about TaskTop. TaskTop Integration Hub connects and automates the end-to-end flow of value across the entire best-of-breed software delivery toolchain, from inception until it's running in production. We help organizations remove overhead and waste that's slowing your organization down by providing easy-to-use, scalable, and reliable integration infrastructure for enterprise IT, and we support nearly 60 tools. TaskTop also enables you to experiment with new tools easily with no disruption to your workflow and helps your teams improve throughput, speed, and collaboration. Our hub extends the power of Micro Focus ALM and Octane to other best-of-breed tools like Jira, TFS, Version 1, and Rally. And for a limited time, we're offering this for free. So point your browser to go.tasktop.com/Octane.io license. And today's speakers. We have David Landsberg, Director of Product Management for Micro Focus. He's responsible for ADM's cross-portfolio initiatives. Until recently, David led HPE Software's renewed focus on mobile testing. David has been in the software development for the enterprise business as long as he can remember and still finds it very exciting. We also have Eyal Cohen joining us today from Micro Focus. He's a Chief Functional Architect for ADM Research and Development and will be providing all of us with a live demo of the DevOps suite. Eyal is responsible for driving the success and integration of product solutions across the entire ADM portfolio, including ALM, ALM Octane, Predictive ALM, mobile, virtualization, performance testing, and functional testing. And last but not least, we have Malcolm Isaacs joining us from Micro Focus. Malcolm is a solution marketing manager for ADM with a focus on Agile and DevOps in large enterprises. During the course of his career in software development, Malcolm has held various leadership positions, including team leader, architect, and software engineer. And just a few housekeeping items here. I don't think this is fully relevant to the new platform we're using. However, I'll just go through all of this quickly. It's recorded for everybody. All the Vivint members will have access to the live recording afterwards. It's going to be posted to the webinar section on the Vivint website, visible for all of us members. Additionally, today's slide deck and webinar recording will be made available to you through a link that we'll email out afterwards. And the control panel. So we have audience members from across the world. If there are questions, you can type those questions in your language of choice, and our system will translate over to the preferred language of the speaker so that they can answer your question fully. Okay, so with all of that, I'd like to go ahead and pass it over to David, and let's get started. David?
Thank you, Matt. So, before we dive in, I want to talk a little bit about Micro Focus, the company, just in case some of you are not familiar with us. So the team here on the call came from the Mercury company. And in the early 2000s, we were acquired by HP, which later split into HP Enterprise and so on. But the Micro Focus company is really a merger between HP Enterprise Software and the Heritage Micro Focus. And we, between us, have a lot of experience around the software development lifecycle. We have over 10,000 enterprise customers, and most of the Fortune 100 use our software and our solutions to release and manage their software lifecycle. Multiple acquisitions, a lot of IP, and really a lot of knowledge specific to delivering software. That's a little bit about Micro Focus.
Okay, so before we delve into the DevOps suite, let's take a look at some of the disruptions that have taken place over the last few years in the software development industry. So going right back to to the waterfall methodology, that's how software used to be developed. Business analysts would gather requirements, and architects would design software based on those requirements, and then the developers would implement the requirements, and then that would get handed over to testers to make sure that the requirements have been implemented correctly. Each phase was very well defined, and the work was handed off from one team to the next. Unfortunately, though, it didn't always work like that in real life. The developers would start working with the architect's design, but they might find that the design isn't scalable, or the design was just incorrect. So the designers would have to go back and make changes, go back to the drawing board, and sometimes the changes meant that they'd have to go back to reassess the requirements. It would often turn out that when the software was being tested, the testers had a different understanding of the requirements than the developers who implemented them. So there'd be rework, and there'd be a lot of rework. And this ended up taking a long time to deliver software. In fact, in many cases, to the point where the customer doesn't need the software anymore because the business has moved on since the requirements were initially gathered. So development teams then moved on to a kind of iterative mode where they do waterfall, but on a smaller scale. Rather than implementing everything in one go, they'd work on smaller, more manageable chunks of functionality, but still going from requirements through to design, implementation, and testing. But then in the early 2000s, the Agile movement started taking place, and that took a different approach. So rather than handing off work to different people at different stages, the Agile team would consist of people who were all working on the same requirements at the same time. And in fact, the whole team would collaborate on the definition of the requirement. And more importantly, they'd define the criteria by which a feature would have been deemed to be complete before they actually go ahead and develop it. And that cleared up a lot of misunderstandings between different teams and different people in the team. And it led to a more collaborative approach. So rather than releasing every 12 to 18 months, teams aim to be able to complete their tasks end to end within a couple of weeks or so. And if necessary, they'd even be able to deliver to their customers every couple of weeks. Now, many organizations found that their development teams were able to get the software ready to the point where it could be deployed into production, but there were clashes with the operations teams. They tend to be very risk averse, and they weren't prepared to take chances on deploying software that hasn't gone through the checks and balances that they require. So to resolve this, the development and the operations teams had to find a way to work more closely together. And this way, the development teams would be able to understand the constraints of the production environment, and the production team would know what the software actually does and what parts of the systems that it impacts. And this essentially gave rise to DevOps, where Dev and Ops are on the same team. Because they're working together, there's much better collaboration, and as a result, teams are able to deploy software essentially at will. So as customers use the software, the team learns about how the software is being used in production, and they can continue to refine the software to ensure the best possible user experience through continuous assessment and analysis. Now, in addition to the disruptions in the software development methodologies, we're seeing changes in the way that applications themselves are being built. So the world's moving away from monolithic services, which essentially means a huge block of code that does everything, towards a more layered structure where each layer has a well-defined programming interface that can be easily tested. So over the last few years, we've seen services becoming very granular to the point where they become microservices with very well-defined functionality that can be easily shared across different applications. And there's a price associated with that complexity. It becomes harder to manage the various connections between the different services and the applications and other services that use them and consume them. And it becomes challenging to test so many different services and environments that they have to run on. And at the same time, the infrastructure has been evolving as well. So from large mainframes, software has moved to more flexible delivery and consumption mechanisms. So today, many consumers are looking to use their software from the cloud with the scalability and reliability that that delivers. And those disruptions have really affected everyone in the industry, and it's happened to us in Micro Focus, and we have gone ahead and embraced it.
That's very true, Malcolm. You probably remember that a few years ago, it was taking us around 1.5 to 2 years to deliver major functionality, a major version out to the market.
And actually, I just lost him again.
Take us a long time to stabilize, build to the point where we could hand it over to our QA teams for testing.
And I've lost him again. All right, let me go. I gotta
do
chat
a lot
with
of
Mark.
manual testing. We didn't have the capacity in R&D to have more than 8 products developed in parallel. And over time, we went through our own revolution. We adopted Agile practices, and over the last few years, we've become a real DevOps organization. We increased collaboration across all our team members. The amount of automation has, of course, gone up across the pipeline. We have continuous integration and continuous testing in every step of the way. We provide builds now to QA basically on an hourly basis. And in theory, we can today deploy whatever is in our development pipeline to production whenever we want. In practice, what we do is we release our SaaS products to the cloud every few weeks, depending on the need and the use case. But we've also boosted our delivery cadence for on-premise products, and we deliver now every quarter right on target. And we have become much more efficient. We have doubled the number of products that we can develop actively in parallel.
So David, maybe we should talk about how we went ahead and effected that change. So really there were many changes that we made. Some of them were quite subtle, and many of them were very radical. So I want to talk about 3 of the changes that had the biggest impact. So the first one was system thinking. The next one was amplifying feedback loops. And the other one was adopting a culture of continuous experimentation and learning that would foster, experimentation and adaptation. So first of all, we changed the way that we thought about our products. We broke down the barriers between the development and the operations teams. We created delivery pipelines that have automated testing built into every step, and we made it easier for us to understand why a build might have failed. And when a build fails, we make sure that there's someone there who's going to be able to fix it immediately. And at the same time, we made it easy for us to deploy to production as a natural extension of the pipeline. And secondly, we implemented these feedback loops between everyone involved in the product. So we collaborate and we share within development, and we monitor the way that the products are being used in production. And we make sure that everyone in the team has access to all the insights and all the analytics that we gather, so that we can continuously assess the different ways that we can make our software better for our users. And the last thing that we did that I'm going to talk about now is to encourage our teams to try things out. So we created these environments where developers can experiment with new ideas without fearing failure. We can perform A/B tests to test our ideas on a small subset of our users. If it's a success, we can roll it out to the rest of the users, and if it's not, we can remove it without any damage. When we make updates to the software, we're very careful to roll it out gradually just in case there's an issue. And if there is an issue, we can fix the issue on the spot and we can minimize any downtime to our users.
But to be truthful, there are, of course, challenges in DevOps, especially when we talk about DevOps at an enterprise scale, especially when there's multiple teams involved. A few examples. There are just a lot of tools involved in the whole process. It's true that you can do continuous integration on $1 a day, and actually if you search for it in Google, you'll see a nice blog about that. But most organizations do need multiple tools. They need the tools to work in harmony, to create visibility end-to-end across the whole process. And with shorter release trains, which is what we do in DevOps, the test cycles can still take quite a long time. Even with high automation rates, what we do see is that we do have thousands of regression test cases, and we need to run them on a large number of environments. So that is certainly a challenge that needs to be addressed. DevOps implementations tend to trigger a high volume of pipeline runs, and that requires the ability to quickly isolate the root cause of a pipeline. It can happen anywhere from the check-in moment all the way to configuring an environment, all the way to pushing code to production. You need to assess the risk impact, you need to assign an owner, you need someone to help you get back on track quickly and turn the red color to green. And there's many people involved in the DevOps process, right? So each stakeholder sees a specific view that is relevant. You have stakeholders that are mostly focused around the backlog status, and there's quality, and there's the pipeline status, and there's the test coverage, and there's the deployment readiness, and so on. And this means that not only must the tools actually be able to communicate, but they must be able to communicate the right type of information across all these flows. And what is always true is that the executives themselves must have visibilities to where they're investing the budget, especially when we're talking about strategic investments. And as the organizations scale their DevOps practices up, teams become more and more autonomous, it really does become harder to track these strategic investments and ensure that the organizations are actually working and prioritizing things correctly. In large organizations, we also rarely see that all the code is brand new code. They tend to depend on older components. Some of those components work with waterfall development methodologies, and that's okay, but you need to be able to work with these well. And regulatory compliance is something that we see a lot, especially in the financial and pharma industries. These regulations are something that we keep top of mind. Another big example of a federal regulation is the GDPR that's now happening across Europe. And we have to comply to those if we want to be relevant in those environments.
So there was a recent Tech Beacon article just from a few months ago in November 2017. Scott Wilson of Atomic Software wrote this article saying that there was a managed service provider of HR software, and they were complaining that their release team was spending its weekends trying to get upgrades out, even though the team had already brought development and operations together to increase the collaboration. And it turned out that the problem was that there were too many disconnected tools in play for them to create an effective continuous delivery pipeline. And they kept getting issues showing up in their weekly releases. So when your tool set isn't integrated smoothly end to end, and your teams and the team members aren't talking to each other effectively, there are some nasty symptoms that arise. So, for example, when teams create a new DevOps pipeline, they obviously have to make it work within their organization. That often requires a lot of work to tie the tools together effectively. So it makes a lot of sense for organizations to plug in an already connected tool chain that's already been proven. It doesn't mean that teams shouldn't experiment and tune their setup, but by sharing the configurations, they can help make their colleagues be more efficient with, with very little effort. When the tools aren't talking to each other, the information flow through the pipeline can be impeded. So when the build is read, and the only information that the team has is the build has failed. They don't necessarily know why the build failed, they don't know what the problem is, and they don't know who needs to take ownership right now and fix it. To get fully on board with the DevOps message, you really need to ensure that there is complete transparency and visibility across the organization. You don't want to wait until the customers are reporting that the app is down. You need to get that information immediately, and you need to be able to act on it immediately. Without a connected tool set, you'll end up with a monitoring application in production screaming that something's wrong, but no one's listening. It will get put in a queue for someone to look at when they're available, but who knows how long that's going to take. And this really goes back to the original problem that led you towards DevOps in the first place. Without an integrated tool set, you'll end up with the same legacy development practices, so you've not really accomplished anything at all. If the systems are connected, though, the whole team's going to get an update that the system is down with the information that the team needs to determine who's responsible for fixing it. And the last point I'd like to make here is that it's expensive to be isolated. In a true DevOps organization, collaboration is key. So you need to find a way of collating data in real time and constantly feeding it to the teams. Manually, that's pretty much impossible. Writing the integration layers yourself is not impossible, but it can be pretty Sisyphean. Tools change all the time, particularly open source tools, and keeping up with those constant changes is a never-ending activity. And as a DevOps organization, you want to speed up delivery and not introduce new bottlenecks.
Okay, so to help our customers with a transition to becoming a more agile and DevOps organization, we put together an enterprise DevOps solution, which we call the Micro Focus DevOps Suite. Original name, huh? But here are the main principles that guided us as we built this offering. First, it must be able to help organizations of all sizes. As an organization grows, its DevOps practices, its tool set must grow with it and continue to support the requirements even across the team lines of different businesses. Most organizations today have a lot of tools in place, whether open source or commercial. And although many of these tools don't actually talk to any of the other tools, the integration is usually through continuous integration server, such as Jenkins. We developed a solution that seamlessly fits into an existing DevOps ecosystem and enables sharing of information across those tools. At the same time, we know that we can't support everything out of the box. So we made sure that our products has open APIs and that our customers and third parties can use in order to easily create connectors that they need on top of these APIs. We also acknowledge that there are many different technologies out there, and our solution must support them all. And our testing tools support a wide range of communication protocols, user interface technologies, mobile devices, and so on. That fit really these modern organizations. But finally, our solution have flexible consumption models to match the different customers' needs, cloud, on-premise, hybrid offerings. So the Micro Focus DevOps Suite, it's really an integrated set of products that help you govern, test, manage, monitor, and improve your software. And what we've done is we've taken a collection of 4 of our state-of-the-art solutions from Microsoft. The ALM Octane offering for lifecycle and pipeline management. Our StormRunner Functional for functional test of web and mobile applications. StormRunner Load, which has the performance testing of web and mobile applications in the cloud or on-premise, and AppPulse for monitoring of performance and user experience in production. But let's quickly take a look at how these products work together.
Okay, so we're going to see a live demo in a minute, courtesy of Eyal. But before we dive into the live demo, I'd like to just take a few minutes to go through a quick walkthrough so that we understand what we're going to see in the demo. So what we're seeing here is kind of the overall picture of how we see DevOps. This will kind of ground us for how we see the demo itself. So on the right hand side, we've got customers using an application, and they're constantly providing feedback to the team who assess that feedback and they prioritize action items. So the team plans items, and they're continuously or constantly refining the backlogs to make sure they're always working on the highest priority tasks. This is the continuous planning on the left. When they're working on a task, the developers are continuously checking their code into the source control system, and they're working on automated tests that run whenever the code is built. There are tests such as functional tests that validate that the code can do what it's supposed to do, performance tests that make sure that the software as a whole and each of the components are able to respond quickly enough, and security tests to identify potential vulnerabilities that need to be fixed. If any of those tests fail, the build process is stopped, the code is fixed, and the tests are run again. Once something's ready, the team deploys it to production. This could be automatic as soon as all of the tests are passed, but most organizations we see tend to need a manual approval before it actually goes live. But either way, the deployment is tested to make sure that it's deployed correctly, which requires continuous collaboration across all of the team members and the rest of the organization. Once it's in production, the team uses monitoring software to continuously assess the user experience and ensure that the users are happy. That leads to further demand and planning of tasks to continue to deliver value. The process doesn't stop. It's a continuous cycle that's refined and optimized relentlessly. So let's see what happens in our real-life DevOps environment. So over here in Micro Focus, our R&D group has built an online store using DevOps methodologies, which helps us show how an enterprise DevOps pipeline should look. I'll show you, we'll see part of the process in the demo in a few minutes, but this is how it works and how the team works together with the tool set. So this is our DevOps team. It's a small team. We've got some really talented people in the team, and everyone knows their role. But in addition to our team here, we also have our customer, who is Susan. So Susan logs in, and she finds out that for some reason her credentials aren't being accepted. Judy, the product owner, gets an alert that there's a problem. Now, the arrow itself here is broken because customers typically don't speak directly to R&D. R&D are usually alerted to this type of failure automatically through the continuous operations monitoring. But depending on the organization, sometimes a service request might be raised, which eventually gets routed through to R&D. But in our case, the product owner gets information about the impact of the issue from the monitoring software. In this case, we're using AppPulse, which monitors software in production using synthetic and real users to continuously assess and optimize application performance. When an issue is discovered in AppPulse, a defect can be opened in ALM Octane directly from AppPulse. Now, as I step through the scenario here, you can see the different parts of the DevOps picture lighting up in the top right-hand corner. So at this point, we now have the product owner assigning an owner for the problem. The product owner is adding an item to the backlog and prioritizing it. The backlog itself is managed in ALM Octane, which manages the delivery lifecycle and provides visibility into the DevOps pipeline. The product owner also makes sure that there is an owner for this issue and that someone is going to take it on and implement the fix for it. So at this point, Annika, our developer, gets a notification from ALM Octane, and she gets this notification within her IDE that she needs to work on the task. So within IntelliJ, she gets a view of her tasks from ALM Octane. She goes ahead, fixes the code, pushes the change, and the software is built by the continuous integration server. In this case, it's being orchestrated by Jenkins. when Jenkins kicks off the build, the team is able to see the Jenkins pipeline and the various jobs that are being executed from within ALM Octane. This is the part of the continuous integration phase. So as part of that, the continuous integration system runs a series of tests. So the first set of tests that we run are the functional tests. In this case, the tests were written by Troy, who's our dev tester, and he's using StormRunner Functional. StormRunner Functional lets you test your mobile and web applications on any environment using an on-demand lab with local or hosted devices. We released that very recently in late 2017. The next set of tests to run are performance tests. So Jenkins runs the performance tests written by Anaya. She uses StormRunner Load to create those tests. StormRunner Load is a cloud-based load testing tool that can scale up to millions of virtual users to ensure that apps can stand up to a heavy load and varying network conditions. Once all the tests have run, the team is monitoring the status of the pipeline. In this case, we can see that there's some red in our dashboard. So we go back, we fix the problems, and once everything is green, at this point, we now know that we've implemented everything correctly, and we're now at the point where we can move to the next step in the deployment pipeline, which is actually releasing the software into production. Once it's in production, we are constantly monitoring the software to ensure that the customer experience is good, and we've got our operations engineer who is particularly interested in the reports that are coming back from Pulse. At this point, he's not the only person who's looking at the dashboard. We have the whole team who've got visibility into what's happening in production, and they're ready to jump in and they can fix anything that goes wrong. A final point before we jump into the actual product demo, I just wanted to note that ChatOps is part of collaboration. It's critical to DevOps teams. Developers and engineers and release managers are all good at talking to each other, but they also need a way of communicating with the tools. So we've developed some ChatOps engines which allow ALM Octane and AppPulse to integrate within your collaboration tools such as Slack, and allow the team members to pull information from the various tools that we have in the DevOps suite. So I think we've seen enough slides. So I'd like to hand over to Eyal at this point, who can maybe share your screen and show us the demo.
Yes, thank you, Malcolm and David. So I'm sharing my screen right now. Let me know when you can see it.
Yep.
Okay. So I'll go through the same scenarios that Malcolm just had. So as Malcolm mentioned, everything starts with a problem in the production. So this is Apples that Malcolm talked about. In Apples, in this case, Apple's mobiles, I can see exactly the production usage and problems and the things that I have on my mobile application. So over here, I can see an overview view of what's going in my production. I can go and see that I probably have a problem over here in a specific operation system or anything else. In the moment I can drill down into a specific issue that I might have in production. Let's say I see over here the response time is not as I expected. I can easily go and submit a defect directly to ALM Octane. So the moment I do it, actually all the information from the defect automatically stored in our ALM Octane. And this is for me a good place to switch to ALM Octane to show you what we have. So ALM Octane is the new version of our ALM, which is mostly targeted the new methodologies if you're working DevOps, Agile, although it also supports Waterfall and anything else that you have. But this is a brand new way that provide you a full visibility of quality and release that you need for your application. In the dashboard, for example, I can see my burn down of my application. I can see the status of my features, the status of my quality. I can see it a very easy look of what the status, the functional status and the performance status, and many, many more. In this example, what I'm going to do, I'm going to go to my defect model over here, and I'll take the defects that I just submitted, let's say 2004, and I'll say, okay, this is the defects that I submitted from Apple's. What I want that the developer will actually start working on it. So I'm assigning this defect to a specific developer. Now, this is what I need to do in Octane. What I'll do right now, I'll act as the developer and I'll open my IDE. So this is my IntelliJ and my IDE. And what we have a plugin to any IDE out there, if it's IntelliJ or Eclipse or Visual Studio, where I can see all this, as a developer, I can see all the assignments that I have directly from Octane inside my IDE. So in this example, you can see at the bottom page, I can see all the user stories that I need to work. And here is the defect that I just saw, that I just been assigned to. So as a developer, the only thing I need to do is right-click it and say, okay, I'm starting working on this defect. And I need to fix the issue. Now, for now, I'm not going to fix anything, but let's say as a developer, I fix the issue. The only thing I need to do right now is actually to check it back, check the code back. And as you can see, automatically the IDE knows that I'm working on a specific defect. I'll commit this defect, and I didn't push it to production. So let me push it for a minute. So I'm doing exactly the same. Git commit file, and I'll choose commit and push to production. And I'll choose push. So what happened right now, Git is connecting to my, IntelliJ is connecting through my Git repository, through my Jenkins, and commit the file using Jenkins. Now Jenkins automatically configured to compile everything and execute all my tests. So what I'm going to do right now, I'm going to jump to Jenkins. And in a minute, I will be able to see that my job has started working. Now, okay, as you can see, this is the full execution. This is the job start working. And this job compile everything and start the test execution. Now, all our tests, functional tests are being executed through StoneRunner functional, and all our performance tests are being executed through StoneRunner load. I can see that the full execution, the job already called my StoneRunner functional regression suite. So what I'm going to do right now, I'm going to jump. I know I'm doing it fast, but this is the time I have. I'm going to jump to our StoneRunner functional solution. This is, as Malcolm mentioned, this is a place where you can store the tasks, and not only store the tasks, actually choose on which environment you want to execute. So we support any web environment, any browser that you want on operation system, and a lot of mobile devices as well. So over here, I can see that the test is already running. If I go to my automation test, I can see this is the test that is being executed on 3 different environments that I chose. And if I go to the result, because the test actually just passed, I can see nothing is running. I can see, yes, the last test was actually passed. And I'll drill down, you can see it passed all 3 different environments, different browsers simultaneously. So StoneRunner functionally execute everything parallelly in order to get the best coverage, environment coverage that is possible. Now, if a test would have failed or a specific environment would have failed, I can actually drill down and compare between different environments. So I can see in one side, let's say, I'll go to the screenshots. I can say Okay, on Windows 10 on Chrome, it looks like this, and on Windows 10 on Firefox, it looks different. In this case, it looks exactly the same because the test passed. If it would have failed, I can also from here submit a defect. I can automatically submit a defect. Let's call it a AOS defect. Let's say the severity is high, and I'll submit it. So this defect will automatically submit it 11001. This is the defect in Octane. And if I'll go to Octane 100 and look for the defect, I forgot 1.1, I think. I don't know, I can't see it right now. I think the filter is different, but all the defects are automatically submitted from here. I can see the defect in Octane. And the next thing that I want to show you in Octane, beside the defect and the dashboard that you saw, I can actually understand the entire quality of my application. So over here, you can see all the application models that I have on my application and all the tests. Let me remove the filter. All the tests that I have in Octane. So I have manual testing, I have automated testing, I have a lot of things over here, and all the tests are automatically traceable to any user stories that I have or any defects that I have, and everything is connected over here in Octane. This is the added value, that I have everything connected in one environment. Now what I can see, I'll add the filter again. This is the test that I know was executed through SRF, and I can see the store on a function, and I can see the test passed. In addition, I can see here all the pipeline that I'm running in Jenkins. So I have a better visibility of the status of everything that is being executed from Jenkins. This is, for example, the full execution is the jobs that was called from the IDE, and Storm functional is a job that just execute the Storm functional test. Now, if I want to directly execute it from Octane, the only thing I need to do is click the run pipeline. The moment I click the run pipeline, Octane through Jenkins execute again all my Storm functional tests. So if I go over here, I can see the Storm functional is being executed again. In a minute, it will start. As you can see over here, and I can understand exactly the status and have a great integration between Octane to Storm functional through Jenkins. And the same things go to SRL. So as you can see over here, my full execution jobs that were triggered from the ID is still running and running my Storm load test. So if I jump to Storm load, I can see this is the test. I'll go to load test. And I can see the AOS web tests that are automatically being called through Jenkins is being currently initialized in order to run. And if I go back to the previous execution of the report, which is this one, I can actually see a full performance report to show me exactly the status, what were executed, how many virtual user I ran, what's the threshold, if I had error or anything that a very good performance engineer will really want to understand from his project. So this is exactly what I wanted to show you for here. So I started in Apple's mobile. I opened a defect in Octane. In Octane, I have a dashboard that show me a full visibility of my application, quality, Agile status, development status. I have a great integration between Octane to Storm functional to execute all my functional tests, and to Storm load to execute all my performance tests. And if I had an issue, a problem that one of my tests found, I can easily open the defect back to Octane. So I'll again have the cycle again to fix the defect, assign to developer, and so on and so forth. That it, David, do you want me to show anything else, or Malcolm?
No, I think that was great. We can go back to the slides, and we're going to have a quick recap. Continue.
Okay, so I stopped sharing. Can you see the deck again?
Yep, we
Okay.
can. Thank you very much, Eyal. That was an awesome demo. Let's just take a quick look at what we saw. So we started out with an issue that was detected in production. The issue was detected using our monitoring tool at Pulse, and the product owner assigned a developer or created an issue and assigned a developer to fix it within our lifecycle management tool, ALM Octane. The developer wrote the code to fix it and initiated a build. The code was written in IntelliJ. Jenkins kicked off a build, and we were able to view the progress of the pipeline from within ALM Octane. The continuous integration system ran the functional tests, which runs the tests on lots of different devices and environments using StormRunner Functional, which is our functional testing mobile device lab and web testing tool. Continuous integration then ran the performance tests, which were performed using StormRunner Load. And finally, our whole team is able to see the system running in production, monitoring the user experience, getting information from the dashboard, and getting the status of the system in production and the user experience in production from App Pulse. This is what we just saw. So, David, you want to close with the suite?
Yeah, so as a final slide, just to recap again, the MicroFocus DevOps Suite, an integrated set of products that helps you do the governance, test, manage, and monitor of your software lifecycle. The 4 products take care of the pipeline management, lifecycle management, the testing of both the functional and performance in the cloud or on-premise while ensuring the user experience. And 2 important things I want to highlight. You can already go to microfocus.com/DevOps Suite and sign up for a demo and read all the information about the solution. There's more detailed info there, or just shoot an email to devops@microfocus.com and we will be happy to answer any questions that you might have on the solution. And speaking about questions about the offering, I think this is a good time, Matt, to go to a Q&A.
Great. Thank you so much, David, and thank you, Eyal, for that fantastic demo, and Malcolm, of course, for opening. We have a number of questions here that came through. I'd like to start from the top. Some of the users that have attended today's webinar are using ALM.net, so they're not using Octane. What happens if they're on ALM.net today? Can they still use the DevOps suite from Micro Focus?
So good questions. Of course, a lot of our install base today is using ALM, and we do have a sync tool that with Desktops help we built that syncs ALM and Octane. So you certainly can use the integration between ALM and Octane, and that will already put a foot in the door. So if you get the DevOps suite, we will take care of the integration for you for the ALM component, and then you can, of course, expand what you have in ALM to the full life cycle using the rest of the tools, our functional, our performance, and our monitoring tools. So the answer is yes.
Okay, very good, David. And we also have a question. One of our audience members mentioned that they're using StormRunner Load. So they're already using StormRunner Load, but they're wondering if they can upgrade to use, Octane and App Pulse as well. So how does that work if they're using one of the products but not all 3?
So we do take into account that you might have some of the products that are part of the suite already. So we take care of all the entitlement in the background. Just need to contact us, and we will, of course, take into account the investment you already have in one of our solutions.
And as part of a follow-on question to that, another audience member posed that, what if you're using UFT today? Does this DevOps suite extend out to a unified functional test, or perhaps Lean FT? Some of the folks that are embracing DevOps have started using Lean FT for unit automated testing.
Well, as part of the products that you get as part of the suite, you do have all the existing capabilities available to you. So if you are using UFT and LeanFT today, they do integrate well both with Octane and with StormRunner Functional. So you would be able to still leverage your investment in the assets of UFT and LeanFT. They connect already today to either StormRunner Functional or to Octane, and you can execute and manage all your scripts using these tools. So yeah, the integrations exist today. We don't remove any of the functionality of these 4 products as part of the suite. On the contrary, we've increased the integrations across them. So you get everything that you would get in a standalone plus more.
Okay, great. And we have an audience member that has a product-specific question with regards to Octane as it relates to the dashboard. The question is whether or not they can configure a central dashboard at Octane that displays consolidated views of features to deployment, including the testing results.
Well, in the Octane dashboard today, you do have a mapping between the user stories and the test results and the quality, the test runs and the quality that's associated with each application module that are mapped into features. So yes, you can configure that. We are working on some out-of-the-box dashboards today that will provide some of these as soon as you log in, but it's really important that you define what an application module is from your perspective. It's your application, but once you do that, you do get the visibility you asked for.
Okay, thanks, David. Another audience member asked an interesting question. He asked whether Jenkins or another CI server is required to trigger the test execution out of StormRunner load, or can ALM Octane trigger itself, trigger the execution itself in StormRunner load?
Well, the current integration is you do need a CI server. They all integrate via Jenkins. We do have direct integrations with UFT today from Octane, and I believe the direct integration for the trigger for StormRunner load is in the works. So it's in development. Shouldn't be too long before that's available as well.
Okay. And one last question here is with regards to manual exploratory testing. One of the audience members is using Sprinter as part of their ALM.NET traditional type of setup in-house. They're wondering if they can continue to use Sprinter and integrate that into this DevOps suite.
Well, actually, as part of our functional testing tool, we've provided a web version of Sprinter. It's a bit more advanced with a few more capabilities, all available right within our StormRunner functional solution. So you would migrate to use that. The assets can, of course, be reused, as with all of our tools, but you would move to the next generation version of Sprinter, which is inside the web UI.
Perfect, perfect. One last call for additional questions. We'll give it a few moments to see if anybody wants to go ahead and type your comments right in the open questions. We have David on the line here and the rest of the team to answer. So give it a few seconds. All right. Just a quick reminder that we do have some upcoming Vivid webinars. Be sure to tune into these. You can see the date and time. One is a SIG talk on quality and testing proven practices. The event URL is right there for your clicking. You'll also get a copy of this presentation after today's talk, and you can go ahead and sign up. We have another one on April 19th. This SIG talk is IT operations and it's predominantly focused around the ops bridge. You can sign up for that one. The URL is there as well. And we do have a short survey. You can opt in for more information from Micro Focus. Mark?
All right, I just pushed that out to the attendees.
Fantastic. And we want to thank you everybody for your time today. We appreciate you tuning in. Hopefully you learned something of value, and certainly if you have any additional questions, please don't hesitate to reach out.
Thank you, Matt, as always, a pleasure, and we'll speak to